very glad to introduce Dr. Ken Lim from Singapore. Dr. Kenneth Lim is a research scientist at the National Institute of Education, Singapore. As you will soon see, Ken is a very talented educational designer. He designs for schools, and he follows the principle that teachers should be at the design board from the start. As for the designs themselves, you will also see that Ken's pedagogical approach is inspired by genetic epistemology and similar views such as Andy diSessa's theory of knowledge in pieces, phenomenological primitives, coordination classes, etc. As for technologies, Ken works with a whole range of technological platforms, from immersive environments to open source hardware and most recently augmented reality. These days, Professor Lim is the lead editor of a special issue of the British Journal of Educational Technology, themed on AR, augmented reality, to be published in 2020. Otherwise, we learned that Ken is a plane spotter. Is that like a train spotter? So you'll have to explain that at some point.
Sure. Okay.
And so, welcome to Grad School of Education. Very much looking forward to it.
Thank you, Doctor. Thanks everyone for taking time to be here today. I didn't get your name. Hi, Zoe. Yeah. And you,
Abhirami.
sorry?
Abhirami.
Abhirami.
Yeah.
Okay. So I'd like to just begin by thanking the school and staff and faculty and the students here for taking time to be here and for inviting me to come. I do have a, okay, so I'll just begin. If I appear unwarmed up, it's just attributed to the jet lag. The sharp-eyed among you, I have actually 300 slides. Obviously, I will not inflict upon you this morning. So the reason I have 300 slides is because we can pick and choose which ones we want to have a look. We want to do a deep dive into depending on the interest level. Okay. Sharp-eyed among you would also see that I have some screenshots of a certain YouTube video on the SESAME channel, which features a certain faculty member, which, depending on whether he was coming today or not, I would have flattered and indulged him, and embarrassed him by reminding him of his talk 3 years ago in 2016. So I'm just wondering whether I should or not, because despite the fact that Andy's not here, did any of you hear what? Because what I'm trying to do in these slides where I include Andy's work is to link it to appropriate points in my own work. But I'm not sure whether to do that because it might not be helpful to you if you're not 100% familiar with Andy's work. So can I just have a rough, maybe Dawn and Lloyd can advise me on this, since you know the audience best.
I mean, you might wish to say just a few words.
Yeah, that's what I was intending to do
dive
anyway.
in, that's what's going to frame.
Sure. Okay. Yeah, I wasn't going to plagiarize. I mean, I'm not that kind of person. Okay, so that explains my brief hesitation in beginning today because I wasn't sure how to frame the talk. Okay. So, like many of you here, I started off my career as a teacher. I've been taught in Singapore schools for about 6 years and spent 3 years in curriculum planning in the Ministry of Education. And for the past 17 years or so, I've been in the National Institute of Education, which is the sole teacher education institute in Singapore, because Singapore is a pretty small country. And therefore, we only have one teacher education institute, which covers both pre-service as well as in-service, including grad education. Okay. Some years back, I'll just start. So some years back, my team and I became. I'll give you the origin story. But some years back, my team and I became interested in the intuitions of novices. And if we look at, well, this slide you don't really need to, this slide, because you're like, Andy calls your university home, so therefore I don't need to give you the whole spiel on intuition. But this slide basically is trying to make a point that there are actually a lot of universities which do focus on the intuition of novices. Which do focus on the intuition as a... Good morning. Thank you for taking time to be here. So there are a number of universities which do focus on intuition, but if you look closely, they are primarily for business schools. So there's Columbia, there's Harvard, there are others, and relatively few focus on the intuition of novices. So that's when we bring in our hero, or I'm going to use the word our because okay. So, he made the point 3 years ago that given the development of technology and methodologies of data analysis, Andy made the point that it is now possible to look at the intuition of learners from a level of granularity which was once not possible. If you want to learn more, just YouTube, Google Andy's YouTube, and it's all there. Okay. So yeah. Now, back to my own narrative. So, as you know, Singapore is part of East Asia, and the East Asian stereotype is that of children being very bookish and very studious and basically relatively disposed to showing off to the teacher how well they know their work. So from a teacher's point of view, actually which teacher wouldn't want students like these, who without being prompted to, would naturally already want to study and would want to show you as a teacher how well they already know their own, how well they are, basically, what I'm trying to say with this particular slide is that the East Asian stereotype is basically a teacher's dream. So if you, for teachers who are, how do I say this? There is a flip side to this though, because the flip side to this is that just because someone is able to give the correct answer, how much do we as the teacher or the educator or the curriculum designer really understand his or her, in other words, do we take the correct answer at face value, or do we have is it within our own value system, and do we have the skill to unpack that answer to try to deconstruct how he or she is thinking? Because if we don't do that, if we don't take the effort to do that, then what might result might be this, which is taken from China's Twitter equivalent of Weibo, which is this particular shot is from the Chinese national examinations, which qualify them to go into college, which is the Gaokao. Gaokao simply means the higher exams. So if everybody knows the correct answer, or if everybody thinks they know the correct answer, then what does that really say about the assessment system? So basically what I'm trying to say is that it's more an indictment of the assessment system rather than something, you're basically reaching a ceiling. Andy kind of tries to make the same point because he talked in his talk about the box of the learner's mind and the inputs and the outputs. And the point he was making is that basically this is still a black box, which he then proceeded to unpack in a couple of examples. So the ostensible output is the easiest to observe, and a lazy teacher might just be content with the ostensible output. But really what behooves us is, as professionals, we need to try to understand the black box. Okay, so, yeah, now, so if the ostensible output is the easiest to observe, what forms might this ostensible output take? He numbered it 1, 2, and 3, and he chose to start off by looking at the output, which is how I also like to start off, because starting off at the output is starting off at the level of familiarity where most of us as teachers or as graduate students in education are already thinking about, which is what I call the received representation, the domain representation, the dogmatic representation of your specific domain. In this case, the domain is physics, or what he calls what Andy calls I can't remember what he calls it, but basically it's applied math into physics, dynamic systems theory, yeah. And then, so this would be one example of a representation of received knowledge within dynamic systems theory. At a much simpler level, I know you can't really make this out properly, but these are meant to represent coins. And the reason they're meant to represent coins is because there was a question in the grade 6 national level examination in Singapore a few years ago about the weight of X number of coins, say 7 coins, the weight of 7 coins in your purse. Now, so this was basically, so the context of this was that this was an examination which every grade 6 child had to sit in order to get sorted into the schools for grade 7. And therefore it was a very high stakes exam. And parents had spent a lot of money in tutoring, in tuition classes, trying to get the students to do well. And one of the questions came up was, how heavy, what is the mass of these coins? Now you can kind of imagine the outrage and furore which this question caused for the parents, because basically from their point of view, they had just spent a ton of money trying to prepare the child for a question for which there is no formulaic deduction. No matter how well you know your mathematics and your formulae, no matter how well you've got your formulae packed in your head, there's no way you're going to derive an answer to what is the mass of X number of coins. So it's either something that the child has a sense of, or the child simply cannot attempt or cannot grasp. In other words, what I'm trying to say here with this dichotomy is that on the one hand, so it's one thing to have the book knowledge about something, and it's quite another thing to be able to apply the book knowledge, to have a sense of what that book knowledge is telling you about in terms of the real world. So as teachers, we know this intuitively, but nevertheless, the overriding narrative in the formal classroom tends to be on excellence in the formal curriculum. So if you remember my earlier slide about formal representations and codifications of domains, regardless of domain, we're all intelligent, we're all sufficiently intelligent in this room to understand what I'm trying to do here. The rows represent the domains. Okay, you can have multiple rows. And the columns represent something else. So in this case, the rightmost column represents what I call the disciplinary codification. So this would basically, as you're well aware of, because we are all equally intelligent, this disciplinary codification is necessarily abstract because it facilitates communication across cultures, but within the same discipline. So if I were to go to Finland, and if I were a geographer, I would be able to communicate with a Finnish geographer using the disciplinary codification of my domain. So the conundrum, or the problem that this poses to a schooling system, to the architect of a schooling system or an education system, is how do we take the novice to the expert understanding of the domain? So therefore, I titled this slide the traditional scaffolding of curriculum. In the traditional scaffolding of curriculum, what is the model? The model is, of course, to take the complex and gradually, to take, well, depending on whether you want to reverse engineer it or to engineer it, but basically to take the to go from the simple to the complex through by way of decreasing the level of scaffolding. So here is a very highly scaffolded learning environment, and then you gradually, as the year builds on, you decrease the level of scaffolding till you eventually reach content mastery. That is the view, or that is the thinking. From the work of my team back home, our point of view is that there's still something missing here, and what we see that our problem with the model of taking the simple and increasing the level of complexity is that even the simplified representation bears little resemblance to the phenomenology of the learner's lived environment. So the phenomenological experiences of the learner's lived environment basically, remember that graph I was telling you about? So over here there's a formal curriculum, and over here is what might loosely be termed the learner's ability to apply what he studies outside of the classroom. So basically, there's still a graph here. Okay, so and Andy more or less said the same thing in his use of a particular video. I'm not sure how many of you attended his talk 3 years ago, but basically in this video, which you can just Google on YouTube, he was showing a child playing with a series of blocks. I won't play, this is just a screen grab, so there's no video playing. Now, okay, so this brings us to one of the foundational graphical representations of this morning's talk, and it goes the way I usually do it. Goes something like this. So most curriculum models, for example, like teaching for understanding or understanding by design, they tend to focus on helping on surfacing learner misconceptions. So, for example, Andy spent quite a lot of time on his talk towards the end, critiquing two particular approaches by Carrie and Chi was one, and then Carrie and someone else. Anyway, but you know what I'm referring to. So basically, thanks, man. So for example, Chi was saying, according to Andy, Chi says from the ontological point of view that learner intuitions need to be, to use his dramatic term, learner intuitions need to be swept away because they are incorrect. And therefore, the purpose of the formal curriculum is to implant a brand new set of learning without cognizance of where the learner is already coming from. So likewise, students come with their misconceptions, and these misconceptions need to be dealt with. Yeah. So that's where a lot of curriculum frameworks focus on, and quite understandably so, because these are the easiest to observe in any learning environment. Okay. Because all I need to ask, all a teacher needs to do, even a weak teacher or an inexperienced teacher, is to pose a question to the class, see how the class responds to it, and then in the debrief with the supervisor say, yes, I did a good job because I helped to surface the misconceptions of so and so. Because all I did was simply ask a question, and the class responded, and then I surfaced a few misconceptions. So there is this Chinese or Mandarin proverb called "ba cao chu gen." So you can tell my Chinese is not very good, but basically "ba cao chu gen" means that if you want to pick up the weeds, you need to get the roots out as well. So this particular photograph is of a principal in Hong Kong, and this was before the current unrest. And basically what he was doing is he was taking me on a tour of his primary school, and there were like no reporters around or anything. There were no teachers, it was just me and him. And then it happened to bump into the gardener who was leading. And then without anyone prompting him or anything, he just spontaneously picked up the hoe and started reading as well. So I found this to be very inspirational because he wasn't doing this to make a show of things. He was simply doing this because as a leader, as a teacher, he just felt moved to help the gardener. And it also kind of like encapsulates the spirit of, if you want to read properly, you need to make sure you get the roots. So how does this relate to this diagram? Well, what are the roots of misconceptions? Because you're familiar with Andy's work, so we see the roots of misconceptions as intuitions. Now, once we start focusing on intuitions, it becomes the question becomes much more thorny and complicated from a curriculum point of view. Because unlike misconceptions, which are easy to examine because they're explicit, intuitions by definition are tacit. So you can't really design a learning environment to surface learner intuition directly. For example, my favorite example is the following, although in terms of the climate of the Bay Area, it doesn't really apply. But for example, if I were to ask you, this is deliberately a weirdly phrased question, by the way. For example, if I were to ask you, what is your intuition about whether it will rain today? Now, that is a hugely artificially phrased question, but what is your intuition about whether it will rain today? Now, no matter what the responses of the learners to that question, it will not represent a strong argument can be made that it will not represent their intuition about. In other words, whatever response you get will not be what you're trying to get at. Yeah. Whatever response you get will not be what you're trying to get at, for a whole gamut of reasons, ranging from communication theory to the mixing of prior knowledge and misconception and all sorts of other things. But from a very fundamental level, in terms of communication theory, obviously, if a figure of authority were to ask a novice or a figure of less authority, in this case a student, something, or a stranger were to ask you something, and I'm like your invited guest. So if I were to ask you something, as Americans, you'd be more spontaneous. But if this were in an East Asian context, there would definitely be a lot of thinking going on in the head before they, I mean, those of you who are teaching here with East Asian, falling into stereotype, but you know what I'm trying to say, sometimes it's more difficult to get heartfelt responses from certain cultures than others, because they're much more reticent as to revealing how they truly feel about a certain topic. Okay? So I'm falling into stereotype. Okay. So that's reason number one why studying intuitions is tacit, is difficult, because intuitions by definition are tacit. However, if we go into the same example, and then if I were to approach it in a much more indirect way, and if I were to ask you something like, did you bring your umbrella with you today? So nowhere in that sentence, did you bring your umbrella with you today, is mentioned the word intuition. And yet, if you think about it, and again an argument could be made that did you bring an umbrella with you today is more likely to give you an inkling as to how the person feels about the weather or the probabilities of the weather than the direct question of what is your intuition about weather or rain today. So what can we learn from this little vignette here? What we can learn is that if we want to design learning environments which design for intuition to be surfaced, we need to design for learning environments which are more indirect, and how exactly, I can give you examples, so that the learner is less self-conscious about what he or she is doing, and therefore will be more likely to respond in a way that gives you a better understanding of how he or she is feeling about that particular concept or topic. So all this is actually what Andy has been talking about, basically we've both been independently working on the opposite sides of the Pacific, and he's of course had more theoretical traction, but what I have to share with you today is just some examples of how we've been operationalizing it on our side of the pond. Okay. So if we were to take this reductio, not reductio ad absurdum, but basically if we were to take this logic flow one step further, if intuitions are the roots of misconceptions, then what of themselves are the roots of the intuitions? So I've already kind of mentioned the lived experience of the learners. Now, this poses a second problem as to designing learning environments which which attempt to surface learner intuition, because lived experiences are much more diverse they're not uniform. In other words, even in a class of say a dozen people like today, there could be like 12 or 15 different lived. In other words, each of us has a different lived experience, and it is beyond the teacher's mandate or control or ability to actually interrogate or influence the lived experience of the learner to that extent. So the primary lived experience which the teacher has influence over is, of course, the lived experience of the learner within the school. So we can control, the learning environment within the school is quite within our control, but we can't really influence much what goes on in the home. So these are the three main problems of trying to study intuition. Firstly, the intuitions by definition are tacit. Secondly, the lived experiences are diverse. And thirdly, even within these diverse lived experiences, it is difficult for the teacher to. There are not many of these lived experiences which are directly within the teacher's ability to control. So now, so far I have not mentioned the word technology, and deliberately so because I don't want to come across as exploiting technology for technology's sake, as we all know. But how do we? The work of my team back home, what we do is we try to intervene at this level here, as shown by this next part of the slide. So basically, since we can't since the actual lived experience of the learner is beyond our control and influence, what we do is we try to work with teachers and we help them to think about what kind of shared work and play spaces can be designed. In other words, what kind of learning environments can be designed at this intermediate level kind of like the example I gave you earlier, the brief one about whether the student brought the umbrella or not, to give them wicked problems for them to interact with, and through the interaction with the wicked problem, basically not derive, but be exposed to a learning environment more within the teacher's control, which would help them to subsequently have a yeah. So to shape their intuitions in a more intentionally designed way, so that more of the iceberg becomes visible to us as instructors, okay, or as curriculum designers. So to shape the learning experiences in a more intentional way, so that more of the intuitions regarding the topic at hand become visible to us as curriculum designers. So in this case, in this sense, we are pretty similar again to what Andy is trying to do in terms of if you look at his work. What Andy has been doing is not intervening downstream, but he has been constructing interventions upstream of where a lot of people operate. Because most curriculum frameworks operate at the level of what is at a much more downstream level. So to try to make this a little bit more concrete to what I've said earlier. If we were to take this diagram and we were to turn it onto its side, like this, okay? If we were to turn this diagram onto its side, the reason for attempting to turn this diagram onto its side like this is to form the relationship between this and what I've showed you earlier, which is this. So you can see that structurally there are similarities between this diagram and what I've showed you earlier. The lived experiences are on the left, the learner conceptions are on the right, and then in the middle is the kind of is kind of where the magic happens. And of course it really depends on everything kind of, so everything kind of hinges upon the design of what goes on in the middle. Because if the design of what goes on in the middle is poor or weak, then from this diagram you would know that if the design of this cloud space is weak, then there's really no, then it kind of defeats the point, because then the intuitions would be just as unhelpful as, I'm not going to use the word incorrect, but as unhelpful as they once were. So basically, the rest of my talk today is basically about giving you examples of how this space manifests itself in different subject disciplines. Okay. So I have two slides on these. So there are 3 rows here, and there are another 3 rows here. Okay. So I have examples from geography, from music and physics in terms of Minecraft, in terms of analog circuitry and engineering, and also in terms of here we're using open source sensors in terms of environmental science and making sense of data literacy. Here we are using we are using robots in a makerly way to help them have a more embodied understanding of mathematics, and this would of course be organic chemistry. So basically, I have examples of these, and if there are particular ones that you'd like to see, we can like kind of diverge from here. I was speaking to a couple of you, and I know that we at least have one math teacher in the room. So maybe we'll start with a math example. Is that all right? Yeah. Okay, so let me just jump to the math example. So just to give you an understanding of the range. So over here on top we have the geography ones, okay. Then down here we have it's used in art, in aesthetics, and then down here we have the electric circuits one. Two examples, one from Minecraft, one from another one, and okay. Then we have the math ones. So let's go to the math one. Okay, I'm going to show you a series of pictures, as you can see, because you already had a preview. I'm going to show you a series of pictures, and try to guess why I took the pictures that I did. Okay, so I'm just gonna cycle through these back and forth. Okay. So obviously here I took a picture of a boy, and why do you think I took this series of pictures?
Doesn't have a phone.
Yes, he's manipulating an abstract object which is about the size of a handphone, right? So basically, the reason I took this series of pictures is because I was focusing on his hands. Yeah. Okay. So Dawes surmises that he's like fidgeting or maybe he's like he's basically interacting with the virtual phone in his mind. Okay, he's interacting with the virtual phone. What else? If it's not a phone, what else might it be? Something that size.
A joystick?
Yeah. Okay. So some of you are really smart, and you already. So Rachel, I'm afraid Rachel is kind of like being so smart that she's okay. So the point I'm trying to make here is that there are some people, some very gifted people, who already have the algorithm, who can basically sort these algorithms out without even necessarily looking at them or manipulating the physical. And this boy is not the only one, because this particular article was from a exchange student in my university, and over here he actually uses the word intuitive. He says, my record setting attempt was completely intuitive. So he skipped some steps on the fly and made it faster. So to some people, mathematics comes more or less intuitively. But of course, that is not the case for most people. So if you look at Andy's talk again, there was one part of his 1 hour talk which he talked about. If you remember, he talked about his example about equilibration of temperature of two different. If you take two different materials of different temperatures and then ask the novice to guess how the temperatures would equilibrate. So then he went on to explain his series of steps. His series of steps is pretty interesting, because he starts off with a discussion of the problem, and then he gets them to think about how their ideas can be articulated through graphing, and then he gets them to do an empirical experiment, and then only at stage 4 or 5, does he actually start to do some direct instruction. So likewise here, what we have been trying to do is for learners who are relatively weak in mathematical literacy, what we have been doing is, I mean, these are basically just the usual kind of like space-time graphs to illustrate concepts such as velocity and acceleration. But instead of direct instruction from the beginning, the idea which I'm now going to show you actually was the idea of one of my math interns, and he wanted his problem. The problem he was interested in addressing was the inability of novice mathematicians to have an embodied understanding of concepts of velocity, of acceleration, and of vectors. So, for example, if I were to do this, so if we were to graph the motion, if we were to graph the forces acting on this pen, what would that graph look like? So he went through a series of iterations, and his early series of iterations with him and his classmates involved basically using simple. He basically used they put the handphone on a motorized cart and made use of the inherent gyroscopic sensors within smartphones nowadays. But the problem with this is, as you can see, the cart did not track straight. So then they went on to iterate. So he came to us and we helped him to. So these are some of our initial. We basically thought of trying to design a bespoke robot, for want of a better word, and then we fabricated a few prototypes, and then basically what we did was we got a school was interested in trying out our approach, and these are grade 7 children, and we got them to yeah. So what was happening here is that if you remember the series of graphs I showed you earlier, about speed time and everything, these graphs, our team member devised a simple UI, a simple user interface, such that the learner could either be presented with the graph and predict the motion, or observe the motion and try to represent the graph. And these would, So this is one simple example of how it was applied in a school in Singapore. And we like the teachers liked this approach particularly because it was compact enough to fit into a regularly sized classroom without needing special logistics for a special room to be booked. Okay. So basically, just the general idea is that. Okay. There are a couple of other things that I can say, but maybe we can go on to another example. Is there a particular example? So since this is a SESAME group, maybe we show a STEM example. Okay. Yeah. Okay. Now next one. So this is a STEM example. This graph is deliberately hard to read, and you're not meant to be able to read it. It's simply meant as a negative example of data representation. Okay. So as a negative example of data representation, the reason I'm showing this to you is because I just glanced at my time at the watch, and I'll use this as the second and final example. So obviously there are different ways of representing data, and this is one way, which if you remember how I began the talk, this would be an example of an expert codification, which would be intelligible to someone who is schooled in the discipline, but unintelligible to someone who's not. Okay? So how might we then improve on this? What might we do to improve the intelligibility of something like this? Well, if this is climatic data, which it is, we could do something like this, okay? Which is basically to overlay the data onto a map, which then lends an additional dimension of space and spatial significance onto the data. This is fine and good, except that the level of granularity of this kind of representation is still not helpful for someone who's a novice in the subject, because this would be, for example, if this were California, say, and this were like Long Beach, and this would be like, say, Sacramento, it would be quite useless. It would be not terribly helpful to tell a student that, oh, it's today you guys can't go out after school because it's raining, but over in Sacramento the weather is fine. So what I'm trying to say here is that the level of granularity is not fine enough to be significant to the learner, because the learner is most likely going to tell you, so what if the kids in Sacramento can have fun? All I'm interested about is that I can't go out after school because the weather here in Long Beach is incremental. So, and as you know, with open source developments recently, we've now been able to take that level of granularity and spatial scale and apply it to the level of the school campus. So the following example is what we've done in several schools in Singapore as well as in Indonesia. What we've done is we've basically put a mesh of sensors onto different schools, I'm going to. I believe everyone here should know what. Yeah. So okay. So so basically it's just. But okay. So the idea here, going back to phenomenology and going back to Andy's work, is of course that intuitively we have an embodied sense of which part of our local lived environment is more comfortable at certain times of the day. The important thing to realize as teachers is that we don't necessarily consciously think about these factors when we make our decisions, but they do influence our decisions nevertheless. So therefore, if there's a way of empiricizing the phenomena, so as to use them in our local classroom, then basically that it's powerful because it brings home the local lived environment as a learning resource for the learner. In other words, it's more authentic to the learner. It's potentially more authentic to the learner to be able to interrogate data from within his or her own local environment, and that is what open source sensors have enabled us to do as teachers. So, without going into the technical details, basically, so the end result is of course a table similar to the negative example I gave you earlier, but the main difference is that instead of just being an abstract set of data, this one actually comes from their own local lived environment. And then of course once it becomes that, it can be used in all sorts of different ways, okay, which we don't have to go into. And it can also be represented in terms of immersive environment, so as to enable the students to have a panoptic understanding of the different variations. For example, if you look here, there are different variables. The obvious one is color, but there's also size. So supposing size and color can be mapped onto something like humidity and temperature, at one shot you can see in your school how the local microclimate is different. So okay. So finally, I'll give you one more series of diagrams, and I'll call it a day. finally, to summarize what I've tried to show you, again, going back to how I began this talk, if we begin with the end in mind, ultimately, we are kind of interested in how the novice is able to interpret the received representation of the expert. Meaning, we want the novice to be able to eventually build mastery towards understanding how domain experts understand the discipline. If we take the approach which I've just described to you, then we place a mesh of sensors around the school. They feed data to the router. The router then subsequently feeds data to the cloud, and then subsequently the teacher can then pull it off either through Google or Microsoft and use it in his or her own worksheets and curriculum materials. Okay, if this is the case, then the questions that the learner will be asking in order to interrogate the data would be questions such as, what does the data tell me? What kind of patterns do I see? When do the patterns occur? And how do I make sense of these patterns? Okay? So basically it is questions regarding data literacy. So if that is the case, then this system can be used in a mathematics curriculum. Remember, I'm trying to relate it to STEM. So if this is the case, then this system of technology can be used in a mathematics M curriculum. However, the same system can also be used in another kind of curriculum design with another set of teachers and another set of students, or the same set of students but in different classes, where the students are not asking questions about the data, but the students are asking questions about the siting of the mesh, meaning whereabouts in the school campus do I site? Would be optimal for me to have a maximal difference between variable x and variable between the same variable. So, for example, a real question which came up with the school was, the children were asking themselves, whereabouts in our school is the best place to study after school? So whereabouts in our school is the best place to study after school? So basically, so they had to come up with a series of criteria, like what do you define by best, and then they investigated their own little, they conducted their own inquiry into their own school, and some thought it was a library, some thought it was other places, and so on and so forth. But I mean, of course, where the actual answer was doesn't really matter, but they were doing these kinds of inquiry questions. So for example, this is one possible set of, these are all possible ways of doing the mesh. Okay, then we get the students actually citing the mesh. So this brings us to the third and final curriculum inquiry point, which is not the math, not the environmental science, but the engineering. So it is not what does the data tell me, it's not where do I put the sensors, but how do the sensors work, how do I code them, how can I make them better, how would I make them function better, what materials would I use to protect them from the elements, and so on and so forth. So these are design questions, these are engineering questions, which are quite different from the others. So what this diagram is trying to do is it's trying to give you a simple diagrammatic representation of how a STEM curriculum can be used using can be implemented in a school using open source hardware. Okay, so basically this is what our sensors look like. We deliberately use sandwich boxes because we want to encourage, we want to pique their interest. Okay, I know some of you have to go, so I'm going to stop here. So in case you have questions, yeah. So I'll just leave this with you because this is a nice slide because it shows the teachers actually fronting the lesson, and we don't front the lesson, we conduct professional development sessions for the teachers to front the lesson. Yeah, is that all right, though? Yeah. Lovely. Thank you. I know it's a bit incoherent, but it's basically, yeah.
question?
Oh, yes,
before
please.
Yeah.
Yeah.
I'm curious about, so thank you. And I was able to see in the presentation the moving from the shared experience to the disciplinary representation. And I'm thinking a lot about the lived experience intuition and whether there can be bridges from that to the shared experience. So for example, when I saw the data of PM 2.5 and PSI and your question about when do you know it's going to rain, I thought, okay, well, I can smell it. I broke my collarbone, so I kind of feel a pain in my collarbone. And there have been lots of fires here, so I know when PM is over 150 because I start to feel really bad. So I'm wondering if students have the opportunity to think about those, how do these measurements actually feel in my body, or how do they feel in my everyday life, as a way to help them interpret the shared experience and interpret what comes from that.
There could be, I mean, potentially, great question. Thanks. I'm not just saying because I'm being politically correct, but it really is a good question because I've been thinking a lot about it myself. One of the reasons I've been thinking a lot about it myself is because I'm trying to understand where my work is located with respect to Andy's work. Andy's work I believe Andy's work is even more upstream than mine because he has a set of generalized P-prims, whereas I'm working at the level of how do the P-prims operationalize themselves within learner contexts, and that's not even where, and that's not to say where the whole lot of other people are working, which is downstream. But to answer your question, I mean, of course, not to patronize, but one way might be that they could they could keep logs, but I personally haven't worked with teachers at that level of just to help everybody understand. Maybe I'll show the iceberg diagram. So you are saying basically your question is okay, yeah. Your question is here.
Yeah, is that possible?
Which is where nobody has been working at right now, because we've been focusing on what do these environments look like. But one way I'm saying, I mean, off the top of my head, one way to do this is by asking them to keep a log. And actually, a pair of my interns did it. They did. I think their line of inquiry was similar to whereabouts in the school is the best place, but they were saying we gave them the census take home, and then they were keeping a log of sensory readings vis-a-vis their level of tiredness and motivation, because the reason they designed this particular activity was because they came across an article or paper saying that I can't remember what, but basically one's local environment influences, well, obviously it does, one's local environment influences your level of motivation to do your work, and they were trying to understand these things a little bit better. Yeah, so it can be done, but that's not particularly where I have a whole lot of experience in. Yeah, thanks. Okay, have a good class.
Thank you.
Yeah.
Can you bring up the table that shows across the many disciplines the various projects you've done?
Sure.
Yeah. So, as we move from left to right, what would you say? I mean, you've been citing Andy's work, but how would you characterize, in general terms, any difficulty that's been recorded in centuries of educational practice with respect to moving from left to right? How would you analyze that difficulty? Is it something about the disciplinary epistemic practices of codifying things using particular media and symbolic forms, etc.? Or is it about understanding something intrinsically about the phenomena of lived experience? Like, why is it difficult to get to that stuff?
I'll give you a facetious response, if I may.
Go for it.
Okay, my facetious response would be something like this. I think it would comprise two parts. The first part would be the first big part would be pragmatism. The second big part would be that we as experts sometimes make the worst teachers, because we don't know, we have difficulty shifting gear to where the novices are. So so we sometimes forget where we started from, because things have come so naturally to us, which is why we're doing well in that. Yeah, that's not a terribly academic way of answering the question, which I suspect you wanted a more academic answer to.
So the middle one, it seems like the middle one is related to music.
Yeah.
And it seems like the picture on the left is maybe somebody tapping rhythmically.
Yeah, I couldn't find. Yeah,
I know how they show picture music in that setting. So if we take that and kids who can tap or clap together, maybe call them some kind of know-how, they're able to do that.
Yeah.
When we surmise they've been able to do it for thousands of years. So how would you characterize the difficulty of it seems like there's some kind of trajectory getting here to musical scores.
Not so much a trajectory, no. You see, in what I usually say, which I didn't say because I was too many things to say, but what I usually say when I show this slide is that this middle part here, and then I do elaborate on the use of word canvas, but this middle part here resembles neither the left nor resembles the right. Resembles neither the left nor resembles the right. So it is not. In other words, in the iceberg diagram, this is the cloud, the shared workspace, right? So this part is not. I know this word has been overused this morning, but I'm going to use it. It's not intuitive for us to understand what it looks like, because if it were that easy, then, as you say, curriculum design throughout the ages would already have taken this paradigmatic view of curriculum design from the beginning, and would not have just defaulted to the much easier way of taking the complex and starting from a simplified representation and working this way. And I don't mean to keep talking about Andy as if he's the only one who's the only, but I believe Andy has, if I understand what I'm hearing when I listen to his YouTube talk, he has always been paddling uphill or upstream, and I can relate to that very much, because it is not a natural thing for a curriculum designer or from an education point of view to so I say again, these environments, the middle part doesn't. If it were to be too much of a, what's the word for it? If it were to be too much of a proxy of either side, then it would fail in its task, because it would simply mean an extension, and therefore there is no trajectory. I'm not trying to portray a trajectory here. I'm simply trying to say how these suggest ways in which this gap might be filled and might be bridged, and I'm using examples where I've seen the bridging work. It's just that I did not have time to go into each of these examples, but as a generic qualifier, I would want to emphasize the word canvas, because these are especially this one is very misleading, because this simply looks as if it's the use of an immersive environment, which kind of resembles this and kind of resembles this, but it is not. It's much more complex than that, because and these also follow the same design principle. The design principle is that these environments are not designed as exemplars by an expert figure for the novice to explore, which is again the paradigmatic default view, but they are instead designed by the novice themselves with all the inherent mistakes that novices make, so that to use the cliche, the thinking becomes more visible. Yeah. So in this particular case, the oxbow leg is actually in the wrong position vis-a-vis the meander, but that is only something which someone who has read about, remember the dichotomy I told you, someone who has read about oxbow legs but doesn't really understand the processes in hydrology about why oxbow legs form would have placed the oxbow leg in this position.
So, what are some common characteristics of the canvases of novice intuition?
Okay, so I usually so this, okay, Ken. What I'll do is I'll answer your question in terms of the design principles. So we usually try to okay. If we were to not take a three-dimensional environment, but just a paper-based worksheet. So on the one hand, we have a textbook. On the other hand, we have a workbook, a worksheet. Okay, okay. So we all know the difference between the two, what they look like, and we know that the worksheet has gaps, has scaffolds, but primarily is still blank for the learner to fill in. So the question then becomes, if this is the case for a paper-based scaffold, how is this, when transposed into the digital realm, what does this digital manifestation look like? And if and when transposed into a three-dimensional realm, what do these what does that look like? So we deliberately design for, we work with the teachers to help them to design for environments which are inaccurate, environments which are inconsistent, and environments which are basically just off in some way. And the learning task then becomes for the students to edit or to mod the environments to make them correct in their eyes. And it of course doesn't matter whether these environments are actually correct or not, but the more important thing is that by attempting to modify, or attempting to edit these environments to make them correct in their eyes, they are actually expressing what they believe the environment should look like, and yeah. So the commonalities of these environments would be that they are editable. They start off as inconsistent to the discipline, and they start off as inaccurate.
Could you explain that in terms of, say, Minecraft, which I see?
Okay, sure. So the Minecraft one was actually quite complex, and again, it was not my idea, but it was the brainchild of another one of my interns. Because the Minecraft one actually is very, very interesting because it combines physics and music, and I'm going to use his own slides. I'm going to use his own slides as the illustration. Okay, so Lionel came up with this year-long project, and his starting point was basically software like GarageBand and other similar things. They attempt to make the process of musical composition. They attempt to scaffold the process of music making, but nevertheless they start off still with a simplified representation of the instrument. So he was wondering if he had, I don't know whether he was wondering or whether he already had this idea that there could be some other way of doing it. Okay, so basically so what he did was he made use of the affordance of node blocks in the environment, that they have inherent musical properties. So then, okay, so then what he's trying to do here is he's trying to basically, okay, and then he also made the parallel connection between the node blocks and the circuitry in Minecraft. So here he's marrying then he attempted to marry the two. And the way he attempted to marry the two was to design for environments where he and his friends could do a composition, could build a circuit, and by building a circuit to make it such that the circuit makes a piece of music. So this is then he designed his own tutorial for his peers. And then basically this is the scaffolding of the tutorial. And then this was the way that I encouraged him to analyze it from a more theoretical framing in terms of discourse analysis. And then these are examples of the discourse. Okay, so there are three examples. So one was this one. Which none of us have heard of, unless you are an adolescent who is interested in Japanese manga. Okay. And then the second example that his friends came up with was this, which is, if you can read the music, I think you can read it, is of course this. Which is from Mozart, with the exception of the note. And the final example was this one, which is this. So basically here, to come back to Dawn's question earlier, the intermediate environment resembles neither this nor that. And is therefore, the intermediate environment resembles neither this nor that. And it's not something which, but the interesting thing, the unexpected thing to me was, and to Lionel as well, was that his peers did not come up with original compositions, but came up with facsimiles of what they already knew. With some reflection, this wasn't too surprising, because if we think about, say, for example, the Korean car industry in the 1970s, when it was first starting out, it basically did facsimiles of existing cars, and then it built up confidence to go on to their own designs. So this is just a general process of learning. Yeah. Yes, ma'am.
Well, it seems to me that there's one issue, many issues. But first of all, how do you find out? I'm thinking about the features that are represented by somebody who has not learned the symbol system, and what features are represented in the symbol system. And for instance, I don't think that when we listen to music we hear the notes. There are notes there, but we don't represent
yes.
notes.
Yes.
Okay.
Yes.
And yet the features that are captured by the standard notation
Yes.
are partial in two senses. They're partial in the sense that they're incomplete, they only represent certain kinds of features. And they're also partial to the kinds of features that can be more easily represented. Okay, but there's a, if you say, what do we know how to do when we know how to clap, for example, to keep time? What's the nature of that knowledge? Well, it would seem to me that we would have to know more about that if we were going to try to make pass through this gap.
Yeah.
Right.
Yeah.
And I think what I see happening here is that you're trying to get to what the symbolic representation represents, but not trying to help the person.
Yes. Yeah, you're quite right. I admit that and I acknowledge that. Lionel was 17 when he did this, and he did not come from a phenomenological or intuitions kind of epistemological trajectory. He was so basically he did what he did because he was interested in it, and I superimposed the thing on top of what he did to in my attempt to legitimize it from a theoretical or publishing kind of endeavor. Yeah, but yes, you're quite right to have identified the mismatch. Yeah, I acknowledge that.
Okay.
Yeah.
If there are no more questions right now, we'll just thank Ken again.
Yeah.
And looking forward to chatting with you.
Of course. Yeah.
Okay.
Thank you, Doc.